Okay, so let us discuss some theoretical question or short question for the tension testing. So what we are doing, tension testing. Applied load is P and cross-sectional area, initial cross-sectional area is A. So what is stress? Stress is, write down stress. Stress is force over initial area. Now, if I do not say anything, it means engineering. Engineering and axial. So commonly we do not use these two terms, engineering and axial, but only by stress we mean engineering and axial. Now what is the other form? Not engineering. Other form is true stress. Now what is the difference? Because in engineering stress we use the original cross sectional area, but if you like think about it, after applying tension the cross sectional area will decrease. As it is decreased, this will continuously decrease. That means the force by this area is not actually exact. So it is at the beginning, but after sometimes it is no longer true. So that is why we do not call it true. It is just engineering. What is true? True is a force divided by area anytime. Area anytime is true stress. So it will change every moment, because every moment my area is changing. That is true stress. Then what is strain? Again, only by strain we means engineering axial strain. But sometimes we do not want to tell these two terms, because we are most of the time we are lazy. Okay, how do we represent it? By a symbol called epsilon, and that is delta L divided by original L. Now delta L is the deformation, original is the original dimension. Now it is actually axial. Now if we are talking about lateral means or transverse, then it will be epsilon T transverse. What is this? Delta diameter divided by original diameter. So whatever side you are taking, you should be consistent in that side. So or maybe delta radius divided by original radius, or maybe delta width divided by original width, or maybe delta thickness divided by original thickness. So you can define ways. Whatever parameter you take, if you take that ratio, if you take the radius, it is ratio of the change in radius divided by original radius. So that is transverse. Now there's another term we call Poisson ratio. Poisson ratio. What is this? It is no. It is ratio of lateral strain divided by axial strain, and this value will be a negative number. Why negative number? Because if you pull it, the length will increase. That means this will be a increase, and this will be a positive number, and the lateral dimension will decrease. That will be a negative number. So it is for tension. If you apply compression, the axial portion will be negative and transverse portion will be positive. Why? If you like compress something, the length will decrease. So axial will be decreasing and the lateral will increase. So that will be positive. So it is vice versa. One is positive, one is negative. So always there is a negative sign, but we do not want to use it. But whenever you see something that the Poisson ratio of a material is 0.2, it is always negative, but we do not tell the negative sign. That is number one. Number two is the minimum value of Poisson ratio is 0 and the maximum is 0.5. It cannot go above it, it cannot go below it. So make sure that you know this, because it will help you a lot in your AP exam. Okay, now so what we will do, we will solve some problem. Oh, something else, let us revise quickly. The stress strain diagram, again this is very important. This is why I am repeating. So axial stress, axial strain. How to find axial stress? P by A, and this is delta L by L naught. So you can see that my P will change, my delta L will change, but L naught and A naught will not change. They will be constant because we are using engineering. Now true stress, true strain, we never use it. It is just a concept. So if you draw the curve for a ductile material, now what is ductile? I told you last class. Ductile means here we are using mild steel, but by ductile we means the material which shows sufficient or remarkable or significant or noticeable, whatever you see, whatever you mean, that before failure it will show sufficient deformation. That means you are seeing it that you are failing. It is elongating, 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 elongating. Sometimes you will fail. You can see it. That is called ductile. Other one is brittle. Now, what is brittle? It will not show any deformation. Suddenly, it will fail. For example, glass. Glass, it fails suddenly. If you do not believe me, that at your home, take a glass and try to press it, and then you will see that there is no deformation, but suddenly it will fail. That is glass. But if you take a rubber band, very easy to fill. Rubber band, very cheap. It is available to everybody's house. A rubber band, pull it, and then you will see it is like elongating, 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 elongating. Then you will feel that is mild steel. Now, mild steel is very popular in engineering. Why? Because we can see the failure. People can believe it. Uh, okay, so, be, oh, I had another example, but I am not showing you. In China, there is a bridge. There is a bridge whose deck is made with glass. That means if you walk on the bridge, you will see anything below it, and it looks like that you are walking on the air. So many people gets scared for two reasons. One is they can see everything down, and they get scared. Second thing, if say I will be scared because I know that glass fails suddenly. I do not know when it is failing. It will not tell me earlier. Okay, so that is one example. One example like why people do not like glass. People like glass only for beautification. The wall you can see outside, the window you can take the light. That is okay. But load carrying member, nobody likes glass because it fails suddenly. But we like ductile material because it will show you that it is failing. It will give you some time, at least 1 month, 1 week, even the mild steel we use in our reinforcement. If it fails, it will give you at least 2 years warning. Before 2 years, it will elongate. There will be a lot of cracks, and by this time, you can easily vacate it. Okay, so long story short, so the diagram will be like this: at the beginning, a straight line, then some non-linear, then the top to come, then it may come down, or it come down or straight, then go up, and then reaches the peak, then it will come down again, again, again. Suddenly it will fail here. It will fail here. So the linear portion we call proportional limit. Okay, 0A. So A is proportional limit, B is yield point. And then this portion, it has no name, it is the plastic region. Plastic region means it will have permanent deformation. The top one is ultimate, and this D is failure. This region is called strain hardening. Strain hardening. This region is called strain softening. And also here you can see the necking. Necking means the cross-sectional area will decrease a lot. Now, what does yield point means? Yield point means up to B, if I release my load, it will go this way, and if I release my load, it will come back to original position. So B is the elastic limit. Elastic limit. Again, A is not elastic limit. A is obviously in elastic, but it is in proportional limit. Proportional limit. PRO, proportional. Again, A is not elastic limit. A is within the elastic region and it is a linear portion, but B is the elastic limit. Sometimes we make it if our gaze or sensor is not accurate, we cannot differentiate this non-linear. Sometimes we may draw this line very straight line if our sensor is not good. Yeah, in that case, AB is the same thing. But ideally, a ductile material will show you linear and non-linear both portion. Even for soil the compression curve is this, like this. The very initial portion is the mm, linear and then mostly non-linear. That is for soil. Even same thing for concrete also. Very small portion is linear. Okay, so yeah, then the area within the elastic region, when some book says within the proportional limit, but to my logic it should be within the elastic. That is called modulus of resilience. Modulus of resilience. Okay, right? Resilience. And the entire area is called toughness. Entire area is called toughness. Toughness or modulus of toughness. So toughness is the energy until failure. Okay, write it down, because whatever I am telling, it is in the MCQ question. Energy up to failure. So in this slide, whatever I told you, it is in the MCQ test. And many of the question will be in your FE exam, guarantee. There must be at least one, I believe 2 or 3 questions should be only on this slide, whatever I am doing it now in this figure. And you must understand, because it is in reinforced concrete design class, it is in steel design class. Uh, so in these 2 classes, most importantly. Okay, so what is toughness? Energy up to failure. What is modulus of resilience? In energy until elastic limit. When some book says energy until linear limit, but only linear limit doesn't make sense, because then we are resilience means elastic. The term resilience means elastic. So by definition, it should be the entire area in the elastic. Entire area means area of stress strain curve, or the energy. Energy until elastic limit is modulus of resilience. And the ultimate, only by strength. If I say what is the strength of this material, it means this ultimate. So strength doesn't mean the failure. Again, strength doesn't mean the failure strength. Strength means the ultimate. Now, in real life, strength means the failure, obviously. But in engineering, we always use this term. So it all about like this term. Now, is it logical or no? Actually, that is a big argument. Say when you drive, so in America we drive on the right side, but if you go to Britain, like UK, United Kingdom, they drive on the left side. Now which one is right? Both are right. Yes, whatever, it depends on whatever we use. So if we use D as a failure, it's okay, but in on all the specification or design standard, we use this ultimate. So we call ultimate as our strength. So even this question is in your quiz. What does strength means? Ultimate stress, failure stress, yield stress, proportionally, or proportional limit. Which one? Ultimate. So this question is again in the MCQ test. Now I forgot one thing. What is modulus of elasticity? It is the slope at the linear portion or at the initial portion. Now, if this portion is linear, slope here and here both will be same. So sometimes we call initial slope is called modulus of elasticity, or slope until proportional limit. Do not say slope until elastic limit. No, then if you say elastic limit, then your curve will be slightly this way. That will be less. So it is the initial slope, or slope in the elastic proportional limit is called modulus of elasticity. We also call it Young's modulus. Young's modulus. So hopefully I covered all the theory required for this, and briefly, oh, where is my cursor? Oh, my cursor come. And last class I showed you this video. I am showing again. The reason is, where is failure? Still 15,000 even. So we are testing. Yeah, no, you can see the necking. So here the after. Okay, so we're at 6 now. Well, I just. Oh, you saw that it failed. I want to say that this necking was after the ultimate stress. After the ultimate stress, necking, we can see the necking. But necking starts actually after the yield. After the yield, it starts the permanent deformation. But we can see it very close to the failure after the yield. And then you can see after failing, my cross-sectional area decreased a lot. Okay, so we will stop this discussion, theory discussion here. Now we will solve some